Pasadena.
Thank you very much. Good afternoon. It's an honor to be here. I believe that climate change is civilization's greatest challenge, but it can also be one of our greatest economic opportunities. And I actually believe it must be, because that's the only way I feel we're going to solve it. I'll tell you why I believe that and how. But first, let me give you a sense of what we have done. I think you all know, but I'm going to try and give it to you in a way that you can visualize it a little bit better. I think all of you know we make a lot of trash. Every person on Earth creates about 1 pound of trash every day. That 1 pound of trash, 7.5 billion pounds a day, goes into landfills. Less well known is how much CO2 trash each one of us creates. It's 31 times as much. Everyone on Earth makes 31 pounds of CO2 trash every single day. And those of us in this room with a higher standard of living, probably about 5 or 10 times as much. So what's amazing, think about this. Every single one of us produces our body weight of CO2 and throws it up into the atmosphere. This is actually a visualization of that. That body weight of CO2 takes 100,000 cubic meters. That's actually to scale. That's the amount of CO2 you produce every single day. It's staggering. So the theme of the conference, what are you adding? Well, you're adding a lot of CO2. That's what we're doing every single day. And we're using this thin sliver of the atmosphere as our landfill for all of that. That's why we're creating so much damage. The extra heat that we're adding to the Earth, because of the CO2 we've placed up there, is equal to 3 Hiroshima bombs every second. It's just staggering how we're altering the planet with the CO2 that we create. All of you know the effects have been catastrophic. You've all seen these pictures. You've all lived these. The storms, the fires, everything. In fact, you saw this picture earlier today as well. But I don't know if everybody knows, 500 million animals died in Australia last month. Like, that's how staggering the results of this are. And that's going to come to humanity for a long time to come unless we change direction. The solution is just 4 words. Stop burning fossil fuels. That's the whole solution. But it's very, very hard because we love our lifestyles. Energy is the single most important industry on Earth. It accounts for all of our convenience and comfort and lifestyle. In fact, this is a graph of the GDP per capita of the world for the last 700 years. You can see it's pretty flat for about 600 of those 700 years. Then it takes off like a rocket ship in the Industrial Revolution when we learn how to harness cheap energy. Energy accounts for 10%, fully 10%, of the entire $80 trillion global GDP. And price really matters. This is a graph showing the market size of different forms of energy as you reduce the price. Every single cent of reduction causes $1 trillion growth in the size of that energy opportunity. That's how important, that's how much price matters. A penny equates to $1 trillion. And people are not willing to pay more. There have been protests all around the world this year. This is just 2 pictures of them, when even tiny increases in people's energy costs occurs in their environments. So how do we make renewable energy cheaper than fossil fuel? If we can do that, then we can solve this problem. That will allow us to stop burning fossil fuels, which is the solution. Well, I believe the answer is Moore's Law. Exponential curves crush linear. Nothing has ever gone down as much or as fast in price and cost and power as computing power. And businesses that smartly use that win. I believe we need to smartly use that to solve the climate change problem. All commodities fluctuate in price, whether it's fuel or coffee or sugar or beef. The only thing that consistently goes down is the price of computing power. And to vividly drive that home, I have a memory card here from 50 years ago. It has 32 wires by 32 wires, a little core, little iron cores. So it's 1,024 bits, or 128 bytes. And here is 128 gigabytes that you can buy on Amazon for $9.95. So in the last 50 years, it's gone down in size, a factor of 100, it's gone down in price, a factor of 100, and it's gone up in power by a factor of 1 billion. So we have more than 1 trillion times more computing power per dollar. Nothing in history has ever gone down 1 trillion times in price, let alone just in our lifetimes. That's what I feel we need to harness. Obviously, many other things in life have harnessed that. I feel we need to harness that in the energy domain. So how can we use technology, computation, this powerful Moore's Law, to reduce energy costs? And what are the big problems that we need to solve? Well, the first one is energy storage, and I'll tell you why energy storage is so important and how Moore's Law can be used there. Energy storage is so important because in 2017, we reached a major tipping point in all of history. For the first time ever, we could produce energy from renewable sources cheaper than fossil fuels. Coal is 6 cents, combined gas is 5 cents per kilowatt hour, wind is 3 cents, and solar is 2. So basically, renewables have won, but just at the wrong time of day, because they only occur when the sun is shining and when the wind is blowing. It turns out it's actually more expensive to store energy than it is to make energy. So if we could have a way of storing energy that was cheap enough, and here's the cost of storing energy, lithium-ion batteries are 25 cents a kilowatt hour, we need to get down to 3. And currently the lowest cost of energy storage in the world is 17 cents a kilowatt hour, which is pumped hydro, which is pumping water up a hill, letting it roll, come back down in a pipe to generate electricity when you need it. Pumped hydro needs that mountain, and we don't have any more places to build that. I started looking, I talked about this a year ago at DLD, at ways to build a pumped hydro plant in a big silo, but that was way too expensive. I looked at trying to have gravel move up a conveyor belt to store energy. That was even more expensive. And even looked at a crane to lift up a big weight and lower that weight back down. And that was the worst. But then the eureka moment came, which was stacking blocks. If you could use computer vision to automatically stack blocks in a tower, the crane would have the use of many more times the weight because it was building a big tower. The computer vision capability to do this only recently became possible. The power of the GPU, the graphics processor unit, same NVIDIA card, for $299 gives you so much computation now that you could build something to do that. So we built a computer-controlled crane with multiple arms that automatically lift 35-ton blocks to store 35 megawatt hours and got down to 3.5 cents a kilowatt hour. We're in striking distance of that magical number of 3 cents where we can beat the price of fossil fuel energy at any time of day. I feel that's so important to allow us to make our electricity renewably. After announcing this last year, we had a huge amount of demand. We're so thankful for everybody here who helped us spread that word. And basically, this is what it looks like. A wind farm with towers that store the energy. And the very first system is being built right now, right near Lugano in southern Switzerland. And it looks like this. It's the automated tower, stacking all the blocks. And we have demand for thousands of these units around the world. And we can't wait to deploy this as fast as possible. That was a way of using Moore's Law and computation to solve a problem in the energy space that previously wasn't possible to get down to that price. That's just one example. Let me give you 2 others. Solar industrial heat. Electricity is what we need for many of our life processes, but solar industrial heat is used for almost all of our materials. All of this building, the steel, the concrete, all of the materials we use need high temperature heat and burn lots of fossil fuels. In fact, this is a graph of different temperatures that people use to make these materials, and everything on the right-hand side of this accounts for 20% of global emissions. So if we come up with a way to replace that heat with solar energy, that would be incredible. Well, right now, concentrated solar that makes a lot of heat from the sun maxes out at 600 degrees. But calcining cement, making hydrogen, those things take 1,000 to 1,500 degrees centigrade. So again, we tried to figure out a way to use Moore's Law, more computation power, to allow solar energy to solve this problem. At a company we started called Heliogen, we looked at thousands of different ways, many different iterations, to try and computer-controlled mirrors, again, using computer vision and AI to try and get that higher temperature and lower cost. We came up with a system that uses much smaller mirrors and computer vision to look at the field of mirrors, so that overhead it looks like this, and this is what the computer sees. The computer sees the individual reflections of every mirror in real time, and at 30 frames per second can make micro adjustments to get very, very high concentration ratios. It leads to something like this. Over on the right, instead of a large target where the sunlight shines, which might be 5 meters diameter and 5 meters tall, we're hitting a target that's the size of a basketball hoop, only 18 inches diameter. So because all the sun's rays are going into such a small spot, we can achieve arbitrarily high temperatures. In fact, we can achieve temperatures 1/3 the temperature of the surface of the sun. With those temperatures now, we can do many things. We can use less materials. We can use less labor to install this because it's all computer controlled now. We can use less calibration because it's continuously calibrated. And now we can make heat from the sun for also less than the price of fossil fuels. Only 1 cent per kilowatt hour, we can make this high temperature heat from the sun, much lower than burning anything. First time in history that you can actually make high temperature heat for cheaper than burning something. from the first time we had fire, we've never been able to do that, and I'm really excited that computation power is part of the answer to make that happen. With this, we can do many things. We can do solar desalination. We can do calcining cement, as I said. We can make hydrogen. And we can do so many thermochemical reactions that I feel we can really make a big impact on reducing global emissions with this technology. And finally, what's the third thing we need to do to change the world? We need to go backwards in time. We need to take carbon out of the atmosphere. We put so much up there. It's very hard to filter CO2 out of the atmosphere, and we're putting so much up there. I told you about that. This is also unbelievable. Since I started my talk, the last 10 minutes, we've put 1.5 billion pounds of CO2 in the atmosphere across the world. Another 1.5 billion pounds went in the atmosphere just since I started talking. So we need to take it out. It's very hard to filter it out because you need to move a lot of air to take out a ton of CO2. You need to move a coliseum's worth of air, 1.5 million cubic meters of air, to get 1 ton of CO2 out. And that's very expensive. The existing methods are way too expensive. So we're looking at a new method to combine the energy storage of Energy Vault and the high temperature, low cost heat from Heliogen to build a system that will move the air, filter the air, use the heat to take the CO2 out. And it effectively is like a super tree. It's like a tree, but 100 times more efficient than a tree. So effectively, we can turn desert into forest. We can take 1 acre of land and do the equivalent of 100 acres of trees. With that, you could take a 390-mile square desert and remove all of humanity's global emissions. Every plane, every car, every truck, every bus, everything you could take out. So I feel this is something we need to do in the next decade. There's $1 trillion to be earned by doing this, but only if we make the price lower than the existing price of fossil fuels. The money will flow to this, I believe, if there's that economic incentive. I think that will trump laws, I think that will trump any change in lifestyle if we can just make it so cost effective, and I feel that Moore's Law is the angle to make that cost effective possible. Finally, look at this new decade. We're standing here, we have to do this in this next decade, I feel. What are the odds that all of us are alive in this exact moment of civilization where we're at this turning point, and we can do it right now? Like, this is the time that I feel we have to do it. You look back to almost the time when every one of us was born. There were 300 parts per million of CO2 in the atmosphere, going up at 2 per year, and now we're at 415, going up at 7 per year. If we can do all these things and go back in time, we can go back and give a planet to our children and grandchildren, the exact same one that we inherited. I really, really hope we can do that. Thank you very much. It's been a great audience.
Next up, we will have Christian Kroll, who is the co-founder and CEO of Ecosia.